Good evening. Yes, after hearing about the LHC and the TMT, now we are getting serious and asking ourselves the question, is Santa compatible with the laws of physics? Because this is something, of course, we all need to know, especially when approached by youngsters saying, is Santa real? So just how many laws of physics does Santa break? I gave you this talk quite a few years ago during the dark days of COVID, so if it sounds vaguely familiar to some of you, you might have heard it before. So who is Santa? Santa is allegedly a portly, jolly fellow with a white beard and a penchant for wearing red suits. But just because he lacks fashion sense does not mean he cannot exist. So the question is, what about the claims that are made about this particular gentleman? It is said, it is claimed, that he visits all households on Christmas Eve to deliver presents to all qualifying children. And qualifying in this context, of course, means are they on the naughty or the nice list? Can we reconcile these incredible feats with our understanding of the way the world works or the way the universe works? And I thought in particular, could I actually write a short talk about Santa using science that I've actually covered in other talks, many of which I've given to BASoc in the past. So I've used various concepts in other talks that I've given in the past, and I've put this talk together. So we're going to examine this sentence closely. Santa visits households on Christmas Eve to deliver presents to children. And we're going to pick this apart forensically and ask ourselves, does that mean he has to violate particular laws of physics? So firstly, how many children does he deliver presents to? Well, we can work out the population of the Earth, about 8 billion. About 1/4 of the Earth's population are children. And let's assume about half of them are eligible to receive presents. Let's assume Santa is quite generous and will give presents to children even if they're not in Christian households. So that means about 1 billion children get presents at Christmas from Santa. That assumes a particular ratio of the naughty to nice list. Let's assume that nobody's on the naughty list and everybody's on the nice list. Certain parents and grandparents may take issue with that particular ratio, but let's stick with that number just to keep the numbers simple to 1 billion. Okay, Santa visits households. So how does he get around? What's his mode of transport? Well, we all know what his mode of transport is. It's a sleigh pulled by flying reindeer. So can reindeer fly? Well, we know that insects can fly, and we know that birds fly, and we know that pterosaurs fly, though you don't see many of them these days. And we know that some mammals can fly. So if all of these various animals can fly, can reindeer fly? Well, if they can, they choose to do so, well, very rarely. They choose to stay on the ground for virtually all the time that we're watching them or photographing them. But remember, if you're a scientist, you have the mantra. Just because there's little evidence for flying reindeer, we must remember that absence of evidence is not evidence of absence. So just because we can't find any photographs of flying reindeer doesn't mean they can't fly. So the jury is still out. There's no evidence there necessarily of breaking any laws of physics. Okay, how fast would he have to go in his sleigh pulled by flying reindeer? Well, he would have to go at something like, to visit 1 billion children, assuming they're scattered over the Earth, he would have to fly at something like 2,000 kilometers a second. Which sounds quite fast, yes, admittedly, but it's only 0.007 of the speed of light. They're written as c. So it's only a tiny fraction of the speed of light. At less than 1% of the speed of light, Santa is not even close to breaking any laws of physics there. So we know from previous talks, you've had a series from me on Fiat Lux, Let There Be Light. We know we've measured the speed of light and we know it's 300,000 kilometers per second. We know that nothing can move through space faster than light can travel through a vacuum. Okay, the universe is expanding and it can expand at any speed it wants to. So yes, galaxies are receding from us faster than the speed of light. But in terms of moving through space and certainly moving around the Earth, nothing can exceed the speed of light. But he's less than 1% of that. No problem whatsoever. He's not breaking any laws there. But if he is moving really fast through the atmosphere, wouldn't we end up with a very hot sleigh and presumably very hot reindeer? Aren't we in danger of having roast reindeer? We know that when meteors or asteroids come into the Earth's atmosphere, it's not friction that makes them hot, it's compression of the air in front of the object that's moving through the atmosphere. Compression of gas produces heat. I told you about this in the ABC of stellar evolution. If you take a large cloud of gas, a large cloud of hydrogen, and allow gravity to compress that cloud will heat up. That is why stars ignite, because the compression of the cloud heats up the cloud. And so we can assume that that would also happen for Santa moving through the Earth's atmosphere. Even if it was aerodynamic, even if you had a really slick sleigh looking like that, you would still have the problem that if you move through the atmosphere really fast, if we know that compression produces heat and we know that hot things glow, almost anything will glow. You are currently glowing in the infrared, not so much in the visible, but if you raised your temperature from 300 Kelvin to 3000 Kelvin, you would be radiating far more light, and if you went to higher temperatures, you'd start to emit visible light and eventually ultraviolet light. So doesn't that mean if this sleigh is moving fast through the Earth's atmosphere, doesn't that mean we should see a very bright light in the sky at certain times of the year? Well, maybe we did. Maybe 2,000 years ago, when people saw a bright light in the sky, maybe that was Santa. I think we've got the timeline slightly wrong to try and use Santa Claus as an example of why the Star of Bethlehem exists. But of course, if we're asking, is it possible that we get bright lights in the sky that can't be identified? Again, of course, that happens. It happens all the time. And plenty of people have quoted, I've seen a bright light in the sky. Maybe what they actually saw was the sleigh. But we don't have to invoke the idea that compression produces heat, hot things glow, therefore Santa's sleigh ought to be visible as a very bright flash of light all over the sky during Christmas Eve. Because remember, we do know about certain matter that's in the entire universe, as far as we understand it, as of studying the universe for the last few decades. There is a type of matter which doesn't glow when you get it really hot. This type of matter not only doesn't glow, it doesn't absorb light, it doesn't emit light, it doesn't reflect light. What type of matter are we talking about? We're talking about dark matter, of course. So if dark matter doesn't glow when you heat it up, well, that's fine. Maybe Santa and his sleigh, and presumably the reindeer as well, are made of dark matter. Let's face it, 85% of all matter in the universe is dark matter. So if it's the majority, well, why can't Santa be made of this stuff? Okay, so that's fine. It also, as an aside, explains why it is that we don't see him on tracking radar, because the radar would just go straight through and not reflect. When NORAD say they've seen Santa coming from the North Pole, they are just lying. You cannot see Santa on radar. They're just lying to children, as if we ever would do that. Santa visits households. So we've done the visiting. He visits households. So how does he get into these various households? How does he get down so many chimneys? Remember, he's a rather portly, rotund fellow. So how can he possibly get down a chimney where the pot on the top is only a few centimeters or so in diameter? He would have to go down thousands of chimneys a second if he's going to visit all of these billion households or so. And so it doesn't seem possible that somebody who's more than 1.5 meters tall and rather round would possibly fit down a chimney. But that doesn't mean he's breaking any laws of physics, because we know it is possible that if you take an atom, let's face it, we are made of molecules, molecules are made of atoms, assuming he's not dark matter for the moment. If he's made of atoms, well, we know an atom is a nucleus surrounded by lots of electrons, but there's no reason in principle why an atom has to be only a nucleus and electrons. You could, in principle, replace all the electrons with another subatomic particle called muons. Muons are a cousin of the electron. They're very similar, but they've got the same properties, the same electric charge, etc. They're simply more massive. And when you work out what that means for an atom, if you were to replace all of the electrons with muons, the atoms would be 200 times smaller, which means Santa would be 200 times smaller. So instead of being a gentleman over 1.5 meters tall, he would just be a centimeter or so high. He would fit down a chimney, No problem whatsoever. So I'm not sure how he would replace all of the electrons with muons, but if he did so, there would be the ability to go down a chimney at great speed, and we wouldn't have the problem of him not fitting. But you might say, oh yeah, that's all very well, but what if your house or apartment or flat or whatever hasn't got a chimney? How would he get in? Well, again, there's laws of physics that apply, and you might say if he's outside a building and the doors are closed and the windows are closed, there's no way he could get inside. That is not true. The laws of physics say if an object, and it doesn't really matter whether we're talking about a molecule or an atom or a collection of molecules, if an object wants to go from A to B and there's an impenetrable barrier between them, it is still possible for the object to go from A to B. It doesn't usually occur in our common sense world, but when we're dealing with the world of the very, very small, when we're dealing with atoms and molecules and other objects like that, we have found from examination, and in fact we found we can build microscopes that are based on this idea that it is possible to go from A to B even though there's an impenetrable barrier between them. So for instance, Santa is a situation called quantum tunneling. Santa could in principle tunnel from the outside of the house to the inside of the house even though there was no door open or no window open. He can just tunnel through the impenetrable wall. That goes completely against common sense, but that's the way quantum theory is. When quantum theory disagrees with common sense is wrong and quantum theory is right. So maybe Santa has figured out how to do this. So Santa is visiting on his sleigh pulled by reindeer, and he's going either down chimneys or tunneling through walls to get to the inside of houses. He does all of this on Christmas Eve. Okay, how does he manage to make all of these deliveries in one night? Even if he's traveling really fast at a fair old fraction of the speed of light, how can he get everything done in 36 hours? Well, quantum theory comes to our rescue once again, because if you ask yourself, well, how does he visit a billion places? Because he can't be in two places at once, can he? Because that would violate the laws of physics. Wrong. That doesn't violate the laws of physics. When we look at the quantum world and look at what subatomic particles are doing, or atoms are doing, or molecules are doing, and we are just made of molecules, remember, it is possible for objects to be in two places at one time. Objects can spin clockwise and anti-clockwise at the same time. An object can be over here and over there at the same time. And it's not limited to just two places. In quantum theory, there is no limit to how many different places an object can be in. So Santa could in principle be in two places at once, or 10 places at once, or 1,000,000 places at once, or 1,000,000,000 places at once. That does not violate the laws of physics as we understand them. If you don't like that idea of Santa being in more than one place at the same time, maybe he has to have a different way of visiting 1,000,000,000 households. And again, our knowledge of how the universe works comes to our rescue, because it might be possible for Santa to manipulate space and time. We know that matter distorts, or warps if you prefer, space and time. We know that the Earth, well, actually not only large objects, any object with mass will distort the space around them. Large objects tend to distort space more. But any matter will distort space and time. And so in principle it is possible, instead of having somebody visit 1,000,000,000 different households, it is possible to think about distorting space and time in such a way that you bring all of these households to you, rather than actually visit all of these households. There's nothing against that in our understanding of general relativity that says you can't distort space to shorten the distance between you and all of these places that you want to visit. That's allowed according to Einstein's general relativity. I'm not too sure how to do that. Maybe Santa has figured out a way to do that. So Santa visits households on Christmas Eve. Okay, the last element we've got to deal with is he delivers presents. Let's assume it's one present per child. Okay, he's got to carry 1 billion presents with him. How is he going to do that? How could he possibly carry all of these? One present for each child, that's 1 billion presents in the sleigh. And the sleigh is presumably only a few meters or so long, a few meters wide, a few meters high. So we can easily work out what the volume of the sleigh is, and we can say, well, that volume couldn't possibly hold 1 billion presents. Well, again, that's not strictly true, because it is possible for an object to be bigger on the inside than it is on the outside. And if you think I'm talking about Doctor Who's TARDIS and it's science fiction, wrong again. This is science fact. As according to our understanding of, again, Einstein's general relativity and the way that matter distorts space, it is possible for objects to be smaller on the inside than the outside because of the way space is distorted. We think that's the case definitely for black holes, which are much bigger on the inside than they are on the outside. And in principle, it's true for other volumes. The idea of a cube 1 meter by 1 meter by 1 meter having an internal volume of 1 cubic meter only applies if space is not distorted by any matter around it. So as soon as you start saying, let's start manipulating space, then in principle, you can make the sleigh bigger on the inside than it is on the outside. So maybe that's how he gets 1 billion presents on board. If you don't like that, there's an alternative, which again doesn't break any laws as we understand them. We think there might be 3 dimensions of space: forwards, backwards, left, right, up, down. But there are many scientists who believe that there are more than 3 dimensions of space. It's just that we find it very difficult to perceive these extra dimensions. Some people believe there aren't just 3, there are many more, maybe 10, 11. 12 dimensions. It's just difficult to see where they are. Maybe Santa has figured out a way of taking the presents and moving them into one of these other dimensions. If you were to move them into the 4th or 5th or 6th or 7th dimension, they would appear to disappear from our 3 dimensions. So maybe that's what Santa does. He puts them into one of these extra dimensions, heads off to the various destinations, and when he gets there, pulls them out of these extra dimensions and puts them under the tree. So again, that's not violating any laws of physics as we understand them. It's simply a level of ignorance as to how many spatial dimensions are actually there. You might say, okay, some of these things might be technically possible and not violating any laws, but surely if he wanted to actually do this, it would need an absolutely huge amount of energy. If we wanted to go really fast through the Earth's atmosphere, if he wanted to distort space in order to make sure he could carry 1 billion presents, wouldn't that need absolutely enormous amounts of energy? Well, yes, it would, but maybe Santa has got access to enormous amounts of energy. For instance, if you are going to start distorting space and time with a black hole, well, a black hole could be used to power the sleigh in the first place. How big a black hole would you need at the back end of the sleigh in order to give you enough energy to send this sleigh at near light speeds? Well, we know that black holes in principle could power a starship and actually literally send us to the stars, not the Musk version, but not just exploring the solar system, but literally send a spacecraft to Alpha Centauri or beyond. A black hole would in principle have enough power to do that. If it can send a starship to the stars, it can certainly power the sleigh. How big would the black hole need to be? A tiny one will do. A black hole smaller than a grain of sand would be easily enough to provide you with the power you need. But there's something else. There's the elephant in the room. What is the energy source that we have been overlooking? The real question we should be trying to answer is, what happens to all the mince pies? Every household, not every household, many households leave mince pies out for Santa. What if Santa doesn't eat them? I mean, who believes that Santa actually eats millions of mince pies? That's ridiculous. So what if Santa could actually take those millions of mince pies and extract the energy from them? How much energy is available? Well, we know the exchange rate between matter and energy equals mc squared. So we can work out, if we know the mass of a mince pie, we can work out how much energy could, in principle, be extracted from a mince pie. So let's do that. 1 mince pie, E equals mc squared. A mince pie is about 50 grams. 50 grams multiplied by the speed of light squared gives us the energy content of a mince pie. It is 5 times 10 to the 15 joules. We'll come back to joules in just a moment, the favorite energy of a physicist. You might think more in calories, but physicists think in joules. Let's assume that a few percent of households leave mince pies for Santa. Well, let's say a few percent, let's say 20 million, just to make the numbers easier. 20 million mince pies multiplied by 5 times 10 to the 15 for each mince pie gives you a total energy available to Santa in principle of 10 to the power 23 joules. And it's difficult to imagine just how much energy that is, so let me convert it into something you might get a handle on. Imagine the energy output of a nuclear power station. A gigawatt power station, gigawatt means it's generating 1 billion joules every second. Imagine a nuclear power station running every second of the day, every day of the year, for 1 million years. That total amount of energy is 10 to the 23 joules. So overnight, Santa in principle has available the total energy generated by a nuclear power station running for 1 million years. And he's got that over the next 36 hours or so. Okay, you say, right, how do you go about extracting energy from a mince pie? To say the energy is there is one thing, but then you have to say, well, how is Santa going to extract this energy from the mince pies? Well, one option is to say you take the mince pie, and what you then do is collide it with an anti-mince pie in the large mince pie collider, which we've just heard about from Sheila. So that is a very efficient way of getting energy from any object, is collide it with its antimatter equivalent. But you can see the problem with this is, where do you get the antimatter mince pies from? So that sort of falls a bit short. Is there an alternative way of extracting a lot of energy from matter that doesn't involve having the antimatter mirror image of that in the first place? And yes, there is. It's not quite as efficient. You can't necessarily get 100% of the energy out of matter, but you can get 5% or 10% or 20% or maybe a bit more by taking the matter and dropping it into a black hole. Now, maybe there's one in the sled anyway, but even if there wasn't, maybe he's just got one on the side and he drops the mince pie into the black hole. That releases energy. The act of matter falling into a black hole, before the matter goes beyond the event horizon into the black hole, enormous amounts of energy could be released. We know this because we've seen it time and time again. We see supermassive black holes. Quasars are galaxies with a supermassive black hole at the center, which are eating lots of matter. Lots of matter is falling in to the supermassive black hole at the centers of galaxies. Okay, that matter is probably not mince pies. It's probably gas and stars falling into the supermassive black holes, but we know that produces huge amounts of energy. So much, in fact, that back in 2020, I actually, during COVID, decided to try and take a picture without using a telescope, take a picture of one of these quasars. Even though this quasar was 25 billion light years away, without using a telescope, it produced enough light that I could pick it up with my Nikon camera, even without a large telescope to collect the light. That shows you just how much enormous amounts of energy are being generated by quasars. So dropping matter into black holes, we know, is extremely efficient. Exactly how much energy could we get out of dropping a mince pie into a black hole? Surprisingly enough, I can't find any data on this topic. No matter how much I've researched it, nobody is working on this problem. I can't find any studies that say if you drop a mince pie into a black hole, you can expect to get 10% or 20% or some fraction of the energy. But based on the fact that we can see supermassive black holes doing this very efficiently, I am pretty sure that this should work. So Santa in principle has access to 10 to the 23, maybe a little bit less than that, joules overnight, more than enough energy to send him around the world and deliver presents to children. You might say, okay, in principle he's got the energy, in principle he can bend and warp space and time and manipulate quantum theory to his advantage. But how does he manipulate space and time? How does he know so much about quantum theory that he can use all of these things to get into the households? One thing we have to bear in mind is nobody said Santa has to be human. Maybe he has skills that we are not really aware of. Remember, children are always asleep when Santa visits, and so no child has actually ever seen Santa, so maybe he does look more like that than the more conventional way we tend to think of Santa. So coming back to the original question, is he compatible with the laws of physics? Or if you prefer, just how many laws of physics does Santa actually provably break? I think the answer is none. So feel free to draw your own conclusion about the existence, or otherwise, of the portly jolly fellow with the white beard and the penchant for wearing red suits. And regardless of what conclusion you come to, may I wish you all a very Merry Christmas. Thank you.